Learn about the storage engine capabilities in SQL Server 2022 this week on Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I'm joined by David Pless, a program manager on the SQL Server team. David, thanks so much for joining us on the show. You are no stranger, and we're so happy to have you on.
Yeah, glad to be back. Thank you.
Awesome. Yeah, I'm glad to have you here again. And today we're going to be talking about SQL Server 2022, continuing our series that we have, and we're going to be getting into the storage engine capabilities. And I thought, as we get started, and I'm really going to let you just run with this, but as we get started, it'd be great to understand where we've been as far as storage engine capabilities goes and where we're going with SQL Server 2022.
Right. I'll touch on definitely the storage engine history and a little more. So it's really kind of just setting the stage for everything. So in previous releases in SQL Server 2016, you may have remembered it was just runs faster, right? It's where we made a number of improvements that drove performance, areas such as the improvements in the setup experience, and we further optimized tempdb. We also introduced Query Store, which is one of my favorite features. Stores query text, execution plans, and performance metrics at the database level. And we also brought a whole set of security capabilities, was always encrypted and dynamic data masking and row-level security. In 2017, it was all about choice. So in this release, you could run SQL Server on Windows or your preferred Linux platform, including container images with Docker. So, and we also started the foundational concept of built-in intelligence with adaptive query processing, and we further improved Query Store. We added the ability to automatically tune workloads by identifying query regression and applying a previous healthier version of a plan. And then in 2019, it was all about industry-leading performance and security, regardless of where your data is stored. So we further improved upon intelligent query processing by adding batch mode on row store, row mode memory grant feedback, and other query optimization improvements. And it was all tied to the database compatibility level, so it really helped with application migrations. Now, we redesigned the database engine recovery process, and this is important because we're going to come back to this. Introducing accelerated database recovery. And there's a lot more, of course. I'm just touching on the key highlights. The point is we built and improved upon this groundwork and implemented new features, in particular, around performance and scalability. So this is Enter SQL Server 2022. So we have great innovations across the pillars. We've laid the foundation with the previous releases of SQL Server. And in SQL Server 2022, we've improved the capability pillars of Azure integration, database and storage engine capabilities, analytics, performance with intelligent database, security, and further extending T-SQL. And in SQL Server 2022, it's really Azure enabled out of the gate. So we can connect and leverage the power of Azure for your SQL Server deployments. But in this overview, in this session, we're really going to be focusing on the SQL Server database engine with new features and improvements that really helps improve performance on large memory servers and definitely in high concurrency scenarios. Okay, so this is
exciting.
We're going to go through this in order. So these are the topics that we're going to cover here. And you may see this slide again in some point in the future. There might be a little more added. So that's kind of a teaser there. But really here, we're just going to be setting the stage on these improvements and features. Some of these are enhancements on existing features where others introduce new options and net new capabilities. Okay, so we're also going to have some other sessions where we discuss these further and demonstrate these benefits. So I'm definitely excited about these upcoming sessions. But again, we're setting the stage for a review at this point. Okay. All right, so let's start with the first one. All right. And in order to really talk about this, we need to talk about the system database, the tempdb database. Now, first, we know that we get one tempdb per SQL Server instance. And tempdb is used by every user database for temporary storage, as well as system internals as a workspace. The more workload we have, the more work we're doing, the more pressure we're going to be putting on tempdb. So tempdb is incredibly critical for performance and overall stability. So it's been like a key point to try to tune. And it's been important for DBAs to recognize this and apply best practices. And we've been making this easier to accomplish really in every release, really starting with SQL Server 2016. But in 2019, we added some new memory optimized tempdb metadata capabilities. This is like an opt-in. And we also eliminated most of the page free space contention with the concurrent PFS updates. Now, in that release, the 2019 release, we thought we're going to be able to address all of the contention points in 2019, but there were a couple of the contention points we still needed to address. So in SQL Server 2022, we've addressed these areas by introducing concurrent GAM and SGAM updates. Now, what are these contention scenarios, right? So under high concurrent workloads, we may have some GAM contention where there's many different threads trying to allocate or deallocate extents on the same GAM page because these updates are serialized. This causes throughput to be decreased, and the workloads that require many updates to the GAM page will take longer to complete. The type of workloads fitting this characteristic, so you may have some of these, are repetitive create and drop operations, high use of table variables, high use of work tables due to cursors or order bys or group bys, or like work files due to hash plans. Okay. Now, the concurrent GAM update feature in SQL Server 2022 adds the concurrent GAM updates to SQL Server to avoid this type of GAM contention. And if the DBA doesn't realize this is happening, they just, don't even necessarily know how to troubleshoot or define this. What they may see is that SQL Server is just faster. It's just faster than the previous release. And
nice.
Right. And when we add concurrent SGAM contention, there'll be more on that improvement potentially in a future session. That is really going to also help further improve performance. So I'm really looking forward to demoing this. I know that we have something planned for this, like a teaser. So we'll be talking about that later. I'm really excited about it. Okay. So shrink database with low priority. This is one of these things like if you need it, you need it. So as many of us know, shrink database and shrink file recovers space by moving pages from the end of the file to unoccupied space closer to the front of the file. And once there's no more pages to be moved, we can shrink and truncate the empty space and release it to the OS. Now, even though there's a lot of DBAs are like, well, we don't recommend doing that. Yes, understood. But even though we don't necessarily recommend shrinking databases all the time, as they usually just reclaim space on usage, customers still need to shrink database files from time to time. The challenge is that using shrink database with shrink file operations can lead to concurrency issues where the shrink process can be blocked by workloads that hold incompatible locks. You don't see it all the time, but for customers in highly transactional environments, it definitely occurs. So the shrink database wait at low priority feature, it's similar to the alter index wait at low priority feature, addresses this concurrency problem by taking a schema modify lock in a wait at low priority mode so that when the shrink is executed in this mode, new queries requiring locks are not blocked by the waiting shrink operation. They jump the queue and continue to execute as shared locks are non-conflicting with other shared locks. So as a result, what was previously blocked by these long-running readers will no longer block new queries. And shrink will time out and abort, as you can see on the slide, if it's not able to acquire a modify lock to queries holding shared lock. And there's no impact on the server in this case. So like, how would this benefit me? You're going to be able to shrink more often and have less concurrency problems as a result. So
Gotcha.
Yeah, if you need it, you need it. And here's another one of those. If you need it, you need it. And wait, really quick before I move on to the next topic. At the bottom of the slide, you see DBCC shrink database with wait at low priority. Here's the command for DBCC shrink file wait at low priority. So I had both of those examples there. Okay.
Nice.
Yeah. So if you need it, you need it. Here's another one of those, XML compression. Okay. So the XML data type that was introduced in SQL Server 2005 has become a common data type for certain scenarios to store unstructured data in SQL Server. So the customers that use it, they tend to rely on it. That's what I mean by if you need it, you need it. Legal, healthcare, financial services all have archival requirements. They all have regulatory compliant requirements that intensify the storage overhead, increasing storage costs. Okay. So we have data compression, but SQL Server did not help with compressing XML data types as they were stored off row and data compression only operates within row pages. So in SQL Server 2022, XML compression will allow customers to reduce their storage footprint without any driver updates or any other changes to applications. And the intent of this improvement is to achieve space capacity savings for the XML data type, that usage, though you may see some IO improvements as well for some workloads. Okay, so you can compress at the table level or at the index level independently. And so it's going to have a really big impact for customers that heavily leverage the XML data type with capacity and potential IO savings as a result. So this is one of those really nice to have features, especially for customers that rely on XML. Okay.
Awesome. Quick question: how would it
Sure.
help with IO performance?
Because you're shrinking. So not only are you shrinking down the data on disk and getting that savings, I have less that I have to pull into into the buffer pool when I'm reading. So the trade-off is potential CPU, slight CPU overhead. So you're trading IO for CPU, but we tend to have IO tends to be where we have the most pain points, memory and IO. So
cool.
It's something to measure. It's certainly something to measure, but this is why I say it's more of a capacity savings rather than you see some potential IO improvement as well. Okay. So let's talk about accelerated database recovery. This is a tough one because there's a lot here. So ADR was a new feature in SQL Server 2019, and there's too much to go into to give it complete justice. So please look into this feature for more information. But in simplicity, basically, we re-architected the recovery process to improve the time it takes to recover a database. Okay. In general, ADR is going to improve database startup time, failover time, and general recovery. And this is regardless of the active transaction time and the number of updates that are performed. Now, again, this was a new feature in 2019. Now, to achieve these benefits, we leveraged a persisted version store in the user database to keep up with row versions instead of putting pressure on tempdb in the transaction log. There's also an internal cleanup process that cleans versions that are no longer needed. Now, there's other components that support accelerated database recovery, but I want you to take note of the persisted version store and this cleanup process. These are the key ones we'll focus on. Now, with that in mind, in 2022, we further enhance accelerated database recovery scalability. The user cleanup process is improved by allowing pages to be cleaned up, even if there are concurrency issues due to workloads requiring table locks. Today, if the cleaner fails to get a lock, we maintain a list of pages for which the cleanup could not take locks. So we go back and clean up these pages at a later sweep. In SQL Server 2022, we check to see if there's any aborted versions before ever adding to this list. So the list is reduced, and as a result, it's a much more efficient process. We've reduced the memory footprint for the persisted version store, and PVS growth is much better controlled. So finally, there's also going to be a multi-threaded version of the cleanup at the instance level. Today, there's only a single cleanup thread per instance, and this is going to further help the cleanup process scale at the instance level. Okay. So in summary, ADR is a strong solution for customers that have long-running transactions and that still need database recovery and it to be fast. And we've much improved accelerated database recovery in SQL Server 2022 to improve memory overhead, improve capacity that was needed, and to improve scalability limitations of the single-threaded version store. Okay, so if you were looking at accelerated database recovery, you've tested it, maybe you've seen some limitations, it gets a lot better in SQL Server 2022.
That's awesome.
Yes. And here's another one. I'm really excited about this one. So this is a feature that's just going to be one of these things that just makes things better and faster. Okay, so there we go. Okay, so the buffer pool scan operation. Okay, the buffer pool is our cache store, right? That stores database pages in memory. And in SQL Server 2019 and previous releases, operations that require scanning the buffer pool can be slow, especially on large memory machines such as the M series or MV2 series. These are these Azure SQL virtual machines, right? It's very large memory machines. And also think about like larger on-prem SQL Server environments. So customers on systems with a terabyte of memory or more may witness really long database creation operations. In some cases, it could be several minutes or more. Now, the reason for this slower experience is there's a single thread that does the work of scanning through the buffer pool, and the impact can be noticed on operations that we have on the slide here, right? Backup and restore, always on failure events, file drop operations, check DB, check table, and so forth. And additionally, and here's the part that gets customers' attention. Additionally, the larger the machine, the greater the impact. So for customers, this can be frustrating and it's counterintuitive. Why would a bigger machine with a lot more memory and processing be less efficient, right? It's because of the serial process and the fact that that serial process is running over so much memory, right? So we're addressing this in SQL Server 2022 by parallelizing the process, the buffer pool scan process, benefiting both small and large databases on large memory machines. And this feature is going to be on by default. So customers are just going to notice the SQL Server is faster, especially on larger boxes, especially when their applications rely on the regular creation of a database or regular maintenance on mission-critical transaction systems. So we're talking about a 20 times improvement or better in many of these cases, yes. And these operations are just going to be so much more scalable, like even on a data warehouse platform. So we're really excited about this feature. I definitely am going to have a session here soon where we showcase a little bit of this, get it a little bit into the meat of the telemetry, and actually demo this capability. So really excited about this. I consider this one of the hero features of SQL Server 2022 as far as the storage engine is concerned. Definitely excited about it. Now, Anna, we just touched on these. This slide could grow, but these are the key features that I really kind of want to set the overview for. I know that we're going to have some demos of these coming up. There's a lot more coming, and I'm looking forward to future sessions. This is
Yeah,
really
thanks so
excited
much,
about this.
David.
Yeah, no
I'm
problem.
super excited. Like,
Yes.
I just learned a lot. I'm sure our viewers learned a lot, and I love that you gave us that teaser at the end, like, hey, we're going to go deeper into this soon. So thanks again, David, for coming on the show. For our viewers, thanks for joining us. We hope this was useful. Please follow along with the SQL Server 2022 series to see more updates. And if you haven't caught up, also catch up on older episodes. And leave us a comment, let us know what you think, and we hope to see you next time on Data Exposed.